Write the number of sp2 carbon atoms present in the final product of the following reaction and the reaction corresponding reaction related sequence and the conditions are given by this is acetylene and reaction with red hot iron tubes at 873 Kelvin followed by carbon monoxide HCl in presence of AlCl3. We are expected to write the final product of this transformation and we are asked to calculate the number of carbon atoms with the hybridization of what? sp2 in nature. We are asked to calculate the product and the number of sp2 carbon atoms present in the product. Whereas this is acetylene undergoes polymerization and that frequent polymerization that is possible with acetylene at high temperature in presence of red hot iron tubes is trimerization. So therefore this is acetylene. When acetylene undergoes trimerization under condition number 1 conditions, with number 1 implies red hot iron tubes at high temperature conditions, this acetylene participates in trimerization. As a result of participation of acetylene in trimerization, that results into the formation of a 6-membered alternative sigma and the pi bonds containing carbon system, that is benzene formation takes place. Whereas this benzene on reaction with carbon monoxide followed by HCl, generates the formyl chloride. This formyl chloride on reaction with aluminium chloride generates formyl cation. This is the formyl cation because in the generated formyl chloride, AlCl3 is acting as Lewis acid and it liberates the Cl as Cl minus. As a result of elimination of Cl as Cl minus, it is converted as formyl cation. This reaction is known as Gutterman reaction. Here electrophilic substitution reaction occurs. At the place of one of the hydrogen, this particular formyl group is getting substituted. Thus here benzene followed by aldehyde, that is benzaldehyde formation takes place. This is reaction number 2. So therefore on the acetylene, heating followed by high temperatures in presence of iron tubes results into the formation of benzene, whereas this benzene on reaction with carbon monoxide followed by HCl in presence of AlCl3 results into the formation of formyl cation. This reaction is known as Gutterman reaction that results into the formation of electrophilic substitution reaction over the benzene results into aldehyde group over the benzene, that is benzaldehyde formation takes place. Whereas the exact structure and the corresponding connectivities of other valencies present on the benzaldehyde is like this. Else if I write one of the Lewis structure of the benzaldehyde to identify number of carbon atoms with corresponding sp2 hybridizations. This is benzaldehyde, whereas this is hydrogen, this is hydrogen. This is one of the valid Lewis structure of the benzaldehyde. We can write another one structure where these bonds are interchanged. Whereas sp2 carbons, one pi bond stands for this is sp2, 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 this is also sp2. This carbon is also associated with one pi bond, implies there are total 7 atoms with sp2 hybridization. The number of atoms with sp2 hybridizations in the final product formed of acetylene on reaction with red hot iron tubes at high temperature followed by addition of carbon monoxide and HCl in presence of AlCl3 is associated with 7 carbon atoms with sp2 hybridization. The next question is, write the major product of the following reaction and the reaction is given by benzenes, 2 benzenes connected with a triple bonded carbon associated with one with NO2 group, other with methoxy group. Such of triple bonded system is there. This is allowed to react with the Hg2 plus followed by water in acidic medium conditions. Whereas this is triple bond system, that is acetylenic system associated with the benzene ring with this group is minus Me group. This group is minus Me group. Minus Me group is deactivating group. Minus Me group is deactivating group, otherwise electron taking group. Whereas this group is plus Me group. This is electron donating group. This is also Me group. This Me group is donating group, hence it is said to be plus Me group, that is electron pair donating group. It increases reactivity of the benzene ring system, and also here what it will do is it increases stability of the cation, it decreases the stability of the cation. Now in the presence of Hg plus, here addition of water is going to be occurring over the triple bond system, then we have to expect the corresponding final product of this transformation. As being Hg plus is a d black element with many of the vacant orbitals, it is acting as electron pair acceptor. Here triple bonded system is having highest electron density, hence in the beginning what happens is with this triple bond system our Hg2 plus makes a interaction and forms a cyclic related system, that is NO2 group is present at one side and this is water methoxy group. Whereas this is having partial positive charge, this is also having partial positive charge. Out of these two partial positive charges followed by the cyclic mercury 2 plus cation related system, here as being this group is plus Me group, it stabilizes the plus charges, hence this particular carbon with positive charge whatever is there, it is relatively more stable compared to the other one. This one is opened by the water molecule. Here water is acting as a nucleophile. As being water is nucleophile here, it opens the three-membered mercury 2 plus in anti-version, that results into the formation of, this will becomes NO2, whereas this triple bond is now no more, it is present in the form of double bond followed by this will be Hg2 plus, and here water molecules are getting attacked over here, it is having unit positive charge. Now it is connected with another one phenyl system associated with what? Methoxy. Whereas here losing of proton takes place, results into the formation of what? OH system. Result into the formation of what? OH system. Further, this what happens is this particular H plus is getting replaced by the H plus, so therefore that results into the formation of phenyl followed by NO2 followed by, this is double bond system, this will become H, now this will become OH followed by, this is phenyl followed connected with human methyl. Now this is present in the form of phenol, it involves in tautomerism, that results into the formation of, this is phenyl followed by NO2, now this will become CH2 followed by C double bond O, phenyl followed by OCH3 group is connected to that. So therefore that C double bond O carbon is the carbon connected with the phenyl system associated with plus Me group, associated with plus Me group. Hence the final product of this transformation is, yes, the groups present as it is, triple bond is now converted as single bond, whereas that plus Me group, stabilizing group connecting cation stabilizing portion is connected by the water molecule, further undergoes ketoenol tautomerism. As a result of this ketoenol tautomerism, it is converted as C double bond O, whereas adjacent carbon is now modified as saturated with CH2. Hence the final product is none other than, this is the groups present in the final product. Now this is converted as CH2, this portion is converted as C double bond O. This is benzene system connected with whom? Methoxy group. Connected with whom? Methoxy group. Suppose if we want to write this one also in the form of benzene, like this. This is the benzene system. Like this transformation takes place. Next is write the product of the following transformation and the reaction is given by, yes, the reaction related conditions are given by, this is 1, 2, 3, 4, that is 3-methyl but1-ine system is allowed to react with the sulfuric acid in presence of Hg2 plus, that is addition of water, that results a new compound, that is X. This X on reaction with methyl magnesium bromide followed by addition of water followed by heating in presence of a dehydrating agent like concentrated sulfuric acid, it results a new compound Y. You were asked to calculate the, we are asked to find the final product Y in the transformation. Whereas in presence of Hg2 plus, the addition of sulfuric acid is nothing but what? Addition of water. That addition is a Marconic of addition. So therefore, as being it is the Marconic of addition, here triple bond is converted as double bond. It results in such a way that H addition takes place at one end to generate stable est followed by OH addition at the other end. This involves in ketoenol tautomerism. So therefore, as a result of tautomerism it results into the formation of a keto compound because it is an enol compound. This is our X. This X is allowed to react with methyl magnesium bromide. In case of methyl magnesium bromide, here our methyl is having unit negative charge. As a nucleophile, this methyl makes an attack over the carbonyl carbon. It is converted as O. This O is converted as OMGBr, followed by this is having methyl. Now here methyl group is present. This on further on reaction with water, that is transformed as alcohol. So therefore this is OH followed by this is also methyl. For this we are applying concentrated sulfuric acid. So heating conditions. Concentrated sulfuric acid is a dehydrating agent. Dehydration is elimination of water. So generally this elimination of water occurs in such a way that it results into the formation of more substituted compound. More substituted compound becomes relatively more stable. Thus it happens in such a way that it should result the more substituted alkene, that is Sedgwick product is expected as a result of this elimination. From here one of the hydrogen, from here OH minus, both together are eliminated. As a result of elimination, it is converted as 2,3 dimethyl butadiene formation takes place. 2,3 dimethyl butadiene formation takes place. Yes, product related information for another one time. This is our terminal acetylene. This terminal acetylene is allowed to react with the water. Marconic of addition of water takes place. Here mercury 2 plus is acting as a catalyst. So therefore Marconic of addition results OH addition at the interior of the triple bond, whereas hydrogen addition at the external part of the triple bond. Triple bond is converted as double bond. It involves in tautomerization. As a result of this tautomerism, it is converted as methyl keto compound. On this methyl keto compound, originally in the question, it is asked as ethyl magnesium bromide. So therefore this ethyl magnesium bromide makes an attack as nucleophile over the electron deficient carbonyl part of this methyl ketone. As a result, it is converted as C2H5 connected oxybromide, magnesium bromide compound formation takes place. This on reaction with water, this particular portion undergoes cleavage as MgOHBr one side, OH one side. So therefore alcohol formation takes place. This is our alcohol with ethyl group. Now in presence of concentrated sulfuric acid followed by heating conditions, elimination, dehydration takes place, that is elimination of water. This is E2 elimination, and in this E2 elimination, more, that is even elimination, more substituted alkene formation is having more chance to form. Hence the compound formed will be appearing like this. This particular type of compound formation takes place.